Well, good morning, everybody. Yes, I've been asked to talk about the Brazilian involvement in LSST, but before doing that, I would like to briefly mention give some background. We have a long tradition in participating in the very large international collaborations, especially in cosmological observational cosmology. In the 80s, we were part of this enormous effort, entire decade, together with CFA. We conducted the Sun Sky Redshift Survey from the Southern Hemisphere. We actually had the participation of South Africa. I even observed South Africa. We had the collaborators, John Menzies and the late Tony Farewell. And we produced the first panoramic view of the large-scale distribution of galaxies, where we found voids and galaxies and walls. And this actually had a huge impact in our understanding of the universe. In the 90s, we have here the collaborators, John Hooker, Margaret Geller, Mark Davis, in this effort. In the 90s, we moved on, the cosmologists of at the time moved on to worry about the mapping of the peculiar velocity field from which you could actually deduce the mass distribution. So we actually conducted two large surveys, all skies, both spectroscopic and photometric surveys, to actually using the Tully-Fisher relation and the DN sigma relation to actually map the velocity field. And we collaborated with people at Cornell, Arecibo, and Dartmouth. In the late 90s, I was actually at ESO. I spent 10 years at ESO, and I was responsible for this. Actually, it was the first public survey of ESO. Now it's a long tradition that ESO has, but this started before VLT, and actually it was done in preparation to a VLT. We actually use a large variety of equipment, but basically towards the end, we started using the first wide field images that there were about. So we basically provided targets. The objective of the survey was to provide targets for the first instruments of VLT, in particular projects like VMUS and GOODS, which had a huge repercussion. So given this past experience, it was not surprising that we would like to get involved. And after the programs that were coming up, to address the issue of dark energy. So this is the roadmap that was presented by a panel organized by DOE in the States. This is about around 2005. And there was this large number of programs, both involving spectroscopic surveys and imaging surveys. And those in green, spectroscopic, and the yellow, imaging. Both for stage 3 and stage 4, basically the type of constraints you could get in the cosmological parameters. So we made a big effort to join these various programs. In fact, we started, we became members of Dark Energy Survey back in 2007, right at the very beginning of the survey, of the project. In fact, the observation started only in 2013. We also joined the third reincarnation of this long digital sky survey in 2008. And later we joined LSST and DESI. And the way we did it, the membership was obtained negotiating in-kind contributions as much as possible, sometimes requiring some combination of cash and in-kind. So this was a very successful strategy for us. And but to do that, we require organizing both the technical side and also creating this network of scientists. So basically we created this institute organization, which was originally actually a project and now became an organization called LINEA. And basically it was meant to give the infrastructure to handle the data that would be necessary to handle these projects and give support to the scientists, the Brazilian scientists involved in this project. So it meant organizing, getting together a multi-talented team involving astronomers, computer scientists, physicists, and people on the network side to improve our connections with the States. So this is actually the number of participants, over 20 institutes in Brazil and abroad that have people affiliated to us in these various projects. So like I said, one of the major in-kind contributions that we provided was software development. And we did that in all the stages of the data flow. So from data acquisition close to the telescope, after data reduction for the validation of the reductions, and also analysis. So let me briefly describe these contributions. So the real-time systems, one of them was a so-called quick reduce that was done for the dark energy survey. It basically took the images produced by DECAM at CTIO and rapidly processed them and tried to evaluate the quality of the images being acquired. So it was in operation from 2013, 2019, and was used not only by the survey, but people, but also all the users from DECAM. We also, the way we joined DESI was producing this prototype we call Quick Look Framework to be able to handle the 15,000 spectra generated in each 20-minute exposure of 5,000 objects. It's a superb instrument. It's during commissioning. Unfortunately, because of the COVID, it was delayed. And it's a superb project that will probably have an incredible result in terms of discriminating the nature of dark energy. And finally, we also provided a prototype for LSST to join all the 189 CCDs immediately after they are taken and they are processed in parallel. So this is something that's ongoing negotiations to actually increase our participation. We also developed two systems, two platforms, one that started running from the very beginning of survey at Fermilab, and this a second one that's now available in NCSA. It basically is a server both for images and catalogs. It has been operating since 2018 with more than 300 users. So all this software was developed by our team. So basically it's different ways of displaying the images, both the whole sky or particular tiles that you have the actual reduction. And also we have a tile inspection so that people at an NCSA can examine, or the collaboration can examine the tiles and to identify possible problems in the image. And also we have a interface to make queries to the database integrated with the visualization tools. And that has been extremely successful and extremely used by people, not only in the collaboration, but also the public in general. By far, this was the largest undertaking that we had. It's a platform that integrates all pipelines. We have tried, I mean, since the complexity, we try to isolate the user from the necessity of handling the data. And basically it's an integrated system, sort of end-to-end. So we have a complete environment of the data. So basically the portal is divided in stages. So we installed the data here. Basically we pull down the data from NCSA. Basically the catalog, the catalog extracted from co-edited images, plus Mango masks that are produced, and we create everything that's necessary to produce value-added catalogs for different applications. So we also have a number of pipelines associated to each application: galaxy archaeology, galaxy evolution, clusters of galaxies, and then in each application, of course, we have different pipelines. This effort has been more than 60 FTEs. It has started back in 2007, 2008, and is in production. That's how we used to analyze the two releases we have made, the year 3 releases, and the ES6 now that's being released to the collaboration. And the nice thing about it is that you have this dashboard that you can actually access any process, any execution that you have done. So that's critical when you're doing these long-term projects involving people distributed geographically. It is a way of record everything that you've done, and you are able to track the input data that you have used, the configuration files, in all the chain of pipelines that led to specific results. This is really a powerful tool, and we will continue to develop for LSST. We also maintain data repositories. This is part of our in-kind contribution to both Sloan and DS. We have a mirror site in Brazil since DR8, so we have kept DR8 to DR17. Like I said, we are the interface to the data from the DS-DR1 at NCSA, and we'll be hosting the data here in Brazil for the SDR2, which is planned for January 2021. We also have the dedicated data center, which is located at NCC, where we have the supercomputer facility. We actually have also access to the supercomputer. We have 2 million CPU hours per year normally, and we have our own machines. So we basically have several clusters totaling 24 teraflops. We have 1.3 petabytes of storage.
And Luiz, there's about 2 minutes to go.
Yeah, I'm done. Anyway, okay, Brazil and LSST. Basically what happened is that the observatory, LSST, were concerned about the connection between Chile and the States, and we managed to provide the infrastructure of the network, a long-haul network. And so, interestingly enough, right now we are one of the few members, native members of the project. So together with Chile and the IN2P3 in France. Basically, we exchange this contribution to have the data flow from Santiago to Boca Raton, and we form a Brazilian participation group in 2015 with 50 scientists, 10 PIs and 40 early career scientists. We are now in the process of submitting, we just submitted a proposal to DOE, NSF, and LSST to actually increase this number of PIs, providing contributions like an independent data access center. So we want to host the data here in Brazil. We have provided 3 pipeline scientists and also providing advanced data products for the project. The advantages of having a data center, of course, is that we have more governance, the data where our pipelines are, so we can actually reuse the existing software that we developed for GES. The big challenge, of course, is scalability. You know, we go from 62 CCDs to about 190 CCDs, 5,000 square degrees to 20,000 square degrees. Basically, we have 40 times the data volume that we had in DES. And this, of course, is a 10-year project, so we really have to prepare now to benefit from the survey when it starts in 2023. This is more or less the timeline. Although COVID has impacted the start of the project, we already have data releases already in 2021 and 2022, and basically simulations. And already in 2023, we'll be having commissioning data from the LSST test camera and later on from the actual camera with the full camera. We also, we were proposing, just talking about transients, we actually proposed to the Templeton Foundation. We actually made the first cut, but we didn't get the grant. The idea was to have follow-ups from the moving objects, especially solar system objects, that LSST will detect, creating this network of about 50 robotic 40-centimeter telescope line north-south of Brazil. This is a project that we still intend to pursue, although, I mean, it's the budget, it's estimated to be around $2 million, and we're still looking for funds for that, but it would be very nice that we have a very strong solar system group here in Brazil. So basically, I think that's it, if you have any questions.
Thank you, Luiz. That's great. I just wanted to quickly ask whether there's any intention for Brazil to leverage its access on SOAR, for example, for any transient follow-up from LSST.
Well, we did plan. I talked to this with the former director of LIneA, Bruno. We talked about that possibility. But you know, given the complex, I mean, it's 30% of the time, and given the complexity and the scientific interest of our community, we decided to, at this time, not to do that. And
Right.
as you know, they have a very strong AON program, which is extremely interesting.
Yes.
But no, not yet. But I think there will be other opportunities in the future.
Great, thanks very much.